evening, ma'am. Academic certificate verification. Today our project on PBL, blockchain-based secure academic certificate verification with QR validation. And our team members are Likita, Nisha, and me. Next slide about our project. These are the contents of our project. We are now explaining about these. Next slide. Academic certificate verification is a critical process in education and recruitment and also in the government jobs. Currently, most systems rely on manual verification, is time consuming and prone and vulnerable to forgery. With these risk of fake degrees, there is a need of system. There is a secure, automated and tamper-proof. Blockchain ensures immutable with QR codes enable instant verifications. Tamper-proof means it will be secure and they cannot access our certificates and they cannot be duplicated by any other persons of our certificates. Next slide. Our problems are like major problem is increasing the use of the fake certificates. Manual verification is long time delays and sometimes taking days or weeks. So there is no fully secure system. Certificates can be duplicated and altered by other peoples and they can also make use of those. Static QR codes can be copied and reused. So, but the most critical issue is current systems verify the data but do not detect fraudulent behaviors. Next slide. We analyze the existing methods of verifications. So manual verification is reliable but slow. So digital certificates is easy for but cannot be duplicated. QR systems are fast but vulnerable to reuse. And blockchains is a secrets but lacks fraud detections. So system fraud on security or speed, not both. So no systems detect the fraudulent usage patterns. So this creates a gap from the smarter than the verification systems. Next slide will be explained by Likita.
Today, fake certificates are a major problem. Our solution uses blockchain technology to create a system where the certificates are secure, verifiable, and impossible to tamper with. Objectives: tamper-proof system. Once data is stored in blockchain, it can't be changed or deleted. Achieved using cryptographic hashing plus distributed ledger. Even if someone tries to modify a certificate, the system will immediately detect it. Instant verifications. QR content certificate ID hash link. Scans get data from blockchains. No need for manually verifications or contacting the universities. Prevent forgery and duplications. Each certificate has a unique hash fingerprints. Duplicate certificates is detected instantly. Transparency and trust. Blockchains in public, verifiable and ledgers. No hidden manipulations. Fraud detection. If hash mismatch, system flag it. Helps detect the fake or altered certificates. Scopes: universities, colleges, online platforms, government certificate system, job requirement companies, international verification system. This system can even be used globally for across the border certificate and verifications. Next slide. Requirement analysis. To build a strong system, we divided requirement into functional and non-functional to ensure the both working and performance qualities. Functional requirement features digital certificate, remove the paper dependency, and then SHA 256 hash creates a unique identity. Blockchain storage prevents the tampering. QR code access, verification, real-time checking, fraud detection, ensure the authenticity. Non-functional security, encryptions plus hashing plus blockchain. Even hacker can't modify the data. Performance, first verification, user should not wait. Scalability works for thousands of users, future ready system. Reliability always gives current result, no false verifications. Usability, simple UI, even non-technical users can use it. Next slide. Methodology. This system follows a step-by-step process. Data input, admin enters name, roll number, course and the mask. This is the row input stages. Certificate generations, digital certificates created PDF for ID contains the student details. Hash generations, SH256 algorithm converts data into fixed length hash. This hash acts like a digital fingerprint. No two certificates will have the same hash. Blockchain storage, hash stored in the blockchain block linked with previous block. Because of hashing, altering one block breaks the entire the chain. Next, QR code generations. QR contains certificate ID, hash reference used for the quick scanning. Next, verification process. Requirement scanners QR. System retrieve the blockchain's data. Compare hash. Our system replaced the traditional easily certificates with the secure digital solutions powered by blockchain, ensuring the trust, transparency, and the instant verifications in the modern world. Thank you. Next slide will continue it by Nisha.
Tools and technologies. We use Python for core logic and system implementation. Flask and Django is used as a backend framework to manage requests and data processing. JSON is used to store certificate data. QR code libraries is used to generate QR codes for each certificate. HTML, CSS, JavaScript are used to design the front-end interface. Web3 is used for connect our system with the Ethereum blockchain. Technology is used. Ethereum blockchain provides decentralized and tamper-proof storage. Smart contracts are used for automatic verification. SHA-256 algorithm is used for secure hashing of a certificate data. QR code system allows instant verification. Basic A can be used to detect fraud detection. Expected outcomes. The expected result of the project is to create a secure and a fast certificate verification system. Certificate cannot be changed because data is stored in a blockchain. Verification takes less than 2 seconds using QR code. Fake or duplicate certificate can be detected easily. System can be used by multiple college or a institution. Performance improvements, verification time is reduced, fraud detection accuracy increases, system efficiency improves, data security level becomes high. Conclusion. We developed a secure academic certificate verification system using blockchain. Data integrity is maintained using SHA-256 hashing. QR code help in a quick and easy verification. Manual work is reduced and process becoming automatic. This system solves problems like fake certificates, duplicate certificates, data tampering. Thank you.
Okay, so come to the first slide. Okay, so what is blockchain?
Yes.
What is blockchain and why is it suitable for certificate verification? Uh,
In
what is
certificate
blockchain?
verification, in security purpose, it will be useful.
For the
Ma'am, because it provides security, transparency, and instant verifications which help prevent the fake certificates.
okay. So
Once
to um how you're going to describe the blockchain in this for the security purpose? Okay. So how you guys doing? How you guys are using this technology in your project?
ma'am, blockchain is not shown as a complex network, but it is implemented backend using hash linked blocks, ma'am, through the secure certificate verifications and generates the unique hash like SHA256 and in hash stored in the system. So
Smart
we should
contract
together form
using Solidity to automate the verification process now.
Okay. So what is smart
It
contract,
stores
Nisha?
certificate. What now?
What is smart contract?
Ma'am, when condition is true, actions happens automatically, like no need for admins or authority.
Hmm. Okay. How do you ensure the QR code cannot be duplicated or misused?
Each certificate data converted into unique hash SH256 algorithm. Ma'am.
For every code, you are creating the hash. Okay.
No.
So how does hashing ensure data integrity? Nikita.
Nikita.
Ma'am,
Yeah.
using SHA and hashing and blockchain, detect the tampering immediately when data is produced.
What is the tamper-proof, Shreya?
Ma'am, tamper-proof means the certificates cannot be altered or duplicated. Ma'am, the any person cannot access our certificates, and
What is a
hash
smart
key, hash
contract?
values are also. Ma'am,
What is a smart contract, Nisha?
smart contract data means.
Ma'am, self-executing a
How
program and
It,
stored in a
it is a
blockchain.
written programming language
the
Solidity.
tools and technologies? Come to the slide of tools and technologies. Okay. So what is this Ethereum? What is this Ethereum?
Ethereum is used for secure, ma'am, security purpose and decentralized storage for certificate hashes.
It supports
And
smart contract,
Hmm.
decentralized and secure. It
Whether
uses
yes, ma'am.
cryptocurrency.
no. I'm asking whether the Ethereum is any application or any programming language. What is that?
It's not, ma'am, not like that, ma'am. It can, for it is used only.
Ah,
It is not programming language, ma'am.
then what is that?
It is the called library. It allows the platform for storage and it like a Google Cloud like that, ma'am.
Yes. So that is it is like platform. Okay. So
Yes, ma'am.
it is a decentralized platform where that it allows developers to build and run applications without relying on the central authority. Okay.
Okay.
So it is like a global computer on the internet where you can store your data securely by creating the hashes. So for this we can call as smart contracts also. Okay.
Okay.
So next, which language you are using in the blockchain? What?
The Solidity, ma'am.
Python, Python, ma'am, for the blockchain logic, hash creation and block links.
In blockchain we use Solidity language.
For the blockchain, you are going to use Solidity language.
And
Okay.
Python for
So,
this.
For
okay.
backend, we use Python, ma'am.
Okay. So come to the system architecture. Okay. Literature. This one objectives and scope. Okay. So zoom this diagram. Okay. So in this diagram, for the university, so there's a certificate. Okay, student. Okay. Anybody will explain this diagram? Shreya,
Yes, ma'am.
explain this diagram.
Here the student provides the academic details to the university, like in digital certificates and their IDs. And next, the university will verify the data and issues the digital certificates, ma'am.
Uh,
At the system, the it processes this data and generates the unique hash using the SHA-256 in the blockchain. And
uh,
in the blockchain, it approves the information,
uh,
like it stores the data in Ethereum blockchain, making it like tamper-proof. It cannot be duplicated or altered.
mm, mm,
And next, in the QR code, it generates
mm,
and link to the certificate and easy access for all the students.
uh,
In recruiter or a company, when a recruiter scans that QR code, it is the system retrieves that data
mm,
and they will verify the system compares the current data with the blockchain hash map. If
mm.
both the match, then certificate will get valid. If doesn't match, it will be tampered and will not valid. It will get invalid, ma'am.
Okay. Okay. So in the you give it, Likita or Nisha, conclude the topic.
Our project presents a secure and efficient solution for certificate verification using blockchain technology. By integrating SHA-256 hashing, blockchain storage, and QR-based verification, we ensure that certificates are tamper-proof, transparent, and easily verifiable. System
Mm,
eliminates the problem of fake certificates and reduce the manually verifications and also efforts, providing a reliable platforms for the students and institutions and overall our solution improves the trust, security and efficiency in the certificate process, and it can be further enhanced with technologies like smart and AI based fraud detection in this future. Tamper power instant certificate verification using blockchain, making the process more reliable and efficient.
okay. So whatever you have done in the phase one, you have to create all those things in the phase two by with the system from the system architecture to everything. Okay. So in the block to
Yes, ma'am.
ensure the blockchain, you have to use the Ethereum only. And if you are going to use in Solidity language means you can use. Otherwise, with the Python, you can use hash codes library and all. Okay, so just see all those things and prepare for the phase two. Okay. So tomorrow you bring the
Okay, ma'am.
phase one sheet. I will put the marks.
Yes,
Okay.
ma'am.
Okay, ma'am.
Okay.
Okay, ma'am.
Okay.
Okay, ma'am.
Thank you.
Okay.
Thank you,
Okay.
ma'am.
Thank you, ma'am.
Okay.